Hello and welcome to my video lesson 5.1 on graphing data. So we're going to do two different examples, but to begin with, the only thing that we really have to learn here compared to any previous year of math that you've done is the difference between discrete and continuous data and what it means to be an independent versus a dependent variable. So let's talk about these and then we'll get into two different examples. Discrete and continuous data. Well, discrete is basically something where you're counting the data. So counting the number of students, the number of apples, the number of whatever it is, laptops. So it's the number of items, and it is going to be exactly a number. Okay, you can't divide it further. It is counting one person or 15 people, but you can't have 5.5 people. You cannot cut down the data smaller than it is shown. Okay. Now, one kind of step further to that is discrete data would also include dollars and cents because you can't cut cents further than 1 cent. 1 penny is the smallest denomination of coin that we have in Canada. And so 1 cent is the smallest we can cut. So you can cut $1 into 100 pennies, but at some point you can stop cutting or you can't cut anymore, and therefore it is discrete data. Okay, what about continuous data? Well, continuous data is any data where you aren't really counting and you can keep cutting it in half over and over and over again. So things like time is continuous. Things like measurements of all sort are continuous. Measurements. So this would be like distance, speed, temperature. Okay, these are all continuous because you can actually cut them further and further in half. So just because I said that it was 20 degrees inside my house doesn't mean it's not 20.1 degrees or 20.2 degrees. We can actually continue to cut in half further and further. And you could not only just go 20.1, but you could go 20.09 degrees or 20.095 degrees. And you can keep getting more and more precise. So that would be continuous data and discrete data. The difference between independent and dependent variables is basically this. Independent are your x values on a graph. Okay. Dependent are your y values on a graph. And usually, you can basically think about it in terms of science ideas with manipulated variables versus responding variables. So this is hard for a lot of people to get straight, but basically the question is, what causes what? Something is the cause and something is the effect. Okay, you have to keep in mind cause and effect. Something is the cause, something is the effect. You cannot change the effect without first changing the cause. So, a graph of height by age as children grow up into adulthood would be, the age would be on the manipulated variable because that is what is changing. That's what you're testing. And the height is responding to the different ages. Okay, it's the cause and effect relationship, independent versus dependent variables. All right, here is our first example with the table of values. Let's just zoom out just a little bit more. There you go. That covers everything. So here is our situation. Mr. Drager loves cookies and his wife makes the best ones. Here's a table of values that shows the number of cookies every day. So here we have a table of values. Now, I will tell you that normally our table of values will have X in the first column and Y in the second. I will also tell you that time is almost always the independent variable or the x-axis. So usually that's pretty safe bet. But if you think about it in terms of this, that does actually make some sense. Also, if we look at the number of cookies left, can you have half a cookie left? No, there's no way, because Mr. Drager would never leave half a cookie uneaten on the counter. That is just wrong. So therefore, we will not have half a cookie. So let's take a look at drawing this out on the graph. 0, 1, 2, 3, 4, 5. I'm going to just label it like that for the number of days. Okay, and then if we look at the cookies, we're going to have, we're going to go all the way to 0. And then we'll go at the highest point, it'll be about 24, but let's just see if we can go 5, 5, 10, 15. Nope, that doesn't work. Oh, I've got an idea. 5, 10, 15, 20, 25. Yes, indeed, that'll work beautifully. 5, 10, 15, 20, 25. Okay, and notice that I'm using just nice even spacing of my numbers and trying to use round numbers instead of just using the numbers that are here. So for you guys, I know the feeling is, hey, there's a difference of 4 between all of these, so let's just use that. But you're going to see how in the next example that will not be as clear. Okay, and so I've done my scale. Okay, so scale will be a mark. Okay, axes titles will be a mark, and the main title will be a mark. Usually, sometimes those can go together. Axes. Oh, axes must have units here. So that's why, you know, main title and axes with units are all important and have kind of separate marks there. So this would be, and I'll tell you that normally what we do is we go y variable versus x variable. So this is a graph of cookies versus time. Okay, and then what we will finally do is actually make our graph. So we've got 0 and then 24, 1 and 20, 2 and 16, so maybe there-ish, 3 and 12, so maybe there. Okay, and since this is, we can't have half a cookie or anything like that, we're going to say these are discrete data points. So we're not going to put a line. No line for discrete data. All right. So let's continue on. One more example. And I highly recommend you pause the video now, try it out for yourself, and see how you do compared to mine. Mr. Drager ate too many cookies and now has gone on a diet and wants to lower his weight. Here's a table of values with his results. Okay, so I have kind of thought about it, and this will still be time down here. Okay, but now this will be my weight. And make sure that you have the units listed. Okay, so this will be day 1, day, and then I think I decided that this could be all the way to actually day 0, and then I could go by 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, so I'm going to end on day 15 roughly. Okay, and then on the weight side, you always still have to start with your smaller values going to your bigger values. I'm going to go with, I think I decided 155 would make it look pretty nice. So 160, 165. Actually, this is not going to work as nicely because, yeah, we have slightly different data than the last time I did this. So this will be 160 and probably 180 up here. Okay, yeah. So this is going to be nice. 170 here. Okay, so then right in the middle here is going to be 165. And right in the middle here will be 175. Okay, yeah, that works out pretty well. And so that would mean this is a graph of weight versus time. All right, so day 1, my weight is 175. Day 3, my weight is 172. I think that would be roughly here. Day 7, my weight is 170. Day 15, my weight is 165, roughly there. All right, and is this continuous data? Yes, because it's a measurement, this will actually be continuous data. So you should use a ruler, just like I am doing right here. And notice that it won't precisely get through all of your lines. You just draw it so that it roughly hits. That would be a line of best fit. That would be the best way to do this. You could try to connect the dots, but that is not as clear. It depends on the situation, but I think this one's good. All right, I hope this video helped you better understand how to graph data. Good luck.